Hello, Dolly. Okay, you see this looks exactly like the problem that we used before, but what the problem is asking is how much this counterweight has to be in order for the resultant moment at B to be zero. This is very important, you know. These cranes work basically in the principle, these cranes of balancing the load. So either the boom moves or the counterweight moves and increases. In this case, let's say this is fixed in that position. It's not going to move, and I shouldn't say fixed, but let's say that it's not gonna change position, but we don't know how much is the counterweight for the total moment at B to produce to be zero. But overall it's the same problem. So you put here, let me see, I have the results from the previous problem that we just did here. I guess they are the same values, 1.5, 0.5, 2000. Yeah, they are the same values everywhere. So I'm gonna just copy these values here because it says that this is going to be 2000. This one here is going to be 1500. This here is going to be 500. And this here is going to be, I don't know, this is what we are asked to calculate. This one here is going to be, I'm going to call it just counterweight. No, because that's going to look like clockwise, right? So let's talk at C, just C. And we do summation of moments at B, or at any point for that matter, at any point. But in this case, we need it with respect to B. It's going to be 0 because the problem is stating that. And we start doing that. The first thing that we do is this force, which is our unknown, times the distance, 7.5, 7.5. And it's counterclockwise, so it's positive, plus 500 times this distance, it's 4. And then we have 1500 times 9.5 negative, and 2000 times 12.5, and that has to be 0. And from here we can solve for C. So I'm gonna add all of these numbers, change the sign, pass it to the other side, and divide by 7.5. So I'm gonna change the signs one by one. I'm gonna put negative 500 times 4 plus 1500 times 9.5 plus 2000 times 12.5. Remember, I'm changing the sign because I'm just getting each one of them to the other side of the equal sign at the map and divided by 7.5. And that, my friends, will be what? Is that the answer that we're looking for? If the problem was asking for mass, for weight, that wouldn't be the answer because this is in kilogram. Remember, I put everything is in kilogram. I put this in kilogram, 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 and these distances are in meters, 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 and this distance will also be in meters. So whenever I pass everything to this side, I will have kilogram per meter divided by meter kilogram. So that would be the answer that we are looking for. If the problem was asking for how much weight you should have at the counterweight, then you have to multiply this by 9.81. But in this case, that's the answer. Easy peasy, lemon squeezy. See you in the next video. Thank you for watching, guys. Take this seriously because this course is the base for every single other upper course that you're going to take in the structural area. Have a good day.